And after this lab, after this week, you can't be late for lab. You'll get locked out just for the sake of your classmates to keep things fair. You will still be able to do the lab, and I'll give you, or hopefully one of your classmates will provide you with the data. So you'll start to do the lab, but you'll be on your own, and you won't get full credit for not, if you're not here, you can't get full credit. Anyway, really quickly with attendance, Ashley is here. Van Camp is back. Wooten, Wooten, is not here. Trahan, Trahan, last name is here. Dickens is here. Clark. Haley Clark, not here. Okay. Inca is back. Isaiah, not here. Copes, not here. Smith is here. Watson
Here.
is back. Yep, Watson's here. Kaylee's not here. Middle name Jade. No Kaylee. All right. Lucas is here. Marley is here. Noah is here. Savannah is here. Mia is here. And if I didn't call your name, just email me. We got to get you added to the roster. All right. So really quickly, before we even do today's lab, I really quickly want to give you a little bit of information about tomorrow's lab. I know I already said this, about the pre-lab that's due on Friday. I know I already said this during lecture, but not everybody's here during lecture. So really quick, I just want to show you, especially for those of you who have not done a lab before. Technically, this is our second lab. But again, if you got started late, then this is your first lab. Anyway, what you're going to do is this, once you click this, and I can show you how on your own time. But once you get to the lab worksheet, this is the master copy. You cannot edit this, so you have to make yourself a copy. To do that, you can follow the instructions that are written at the top of any lab worksheet, or it's very simple. You can just go to File, make a copy, name it whatever you want, and then boom, there you go. And then that's your copy, and that's what you're going to fill out when you do a lab. So that's how you get the lab worksheets. But anyway, really quickly for next week's pre-lab, again, the pre-lab is due Friday, and you can't be late on pre-labs, and that's one of those few things I'm picky about because you need to be prepared to come into lab before you come here because it's a team effort. So if you're unprepared, then your classmates suffer, and that's not fair to them. But anyway, one of the things I want to point out is these lab worksheets have a lot of links. That's because I've been doing this for about 10 years now, and every semester when I ask for feedback, I get the same feedback, and it's always conflicting feedback. Some students say your worksheets have way too much information on them, they're too long, it's overwhelming. So then I make them shorter. Meanwhile, other students are like, there's not enough information on these worksheets. I don't know what I'm doing. I need more instructions. So my way to compromise here is just have a worksheet with a lot of links to where you can open up and go to this information that you need. But if you're the kind of person who finds it that overwhelming, if you see here at the top of next week's lab, there's a link that'll take you to a long version of the lab that you can do instead that has all the information on one worksheet. That way you don't have to deal with all those links. Does that make sense? So again, if you feel like the links are too much for you, do the other version. But anyway, really quickly, next week, again, your pre-lab is going to be doing these. You're going to have 3 little quizzes. And if you don't know what I mean by quizzes, I mean this, right? So this week, these little quizzes that you had to do online were extra credit. This week, they're required. Excuse me. Stay here. Yeah, there we go. So again, you're going to watch a video that's about 13 minutes long while answering those questions. Then you're going to watch another video while answering some questions. Then you're going to read this introduction and then take a little quiz based on the information presented in that introduction. Does that make sense? It's the only 3 things you're going to do. For each one of those 3 things, when you're done with your quiz, it's going to give you your results. You're going to take a screenshot of those results and you're going to insert them into there. This might sound overwhelming, and if it is, let me know. I can meet you online and show you. Once you know how to do it, it's really simple. So when the time comes, again, you don't have to do any of this alone. If you need help, meet me online. I will show you how to do it. So any questions about what's expected of you for Friday? Okay. Let's move forward then. And again, if you do have questions and you just didn't want to say it out loud, just get in touch with me in person. So here we go. The hypothesis testing. This is the lab that we're doing today. Again, it's going to be a little bit longer, so I apologize in advance for that because you're going to be learning things in today's lab that you're going to need for the rest of this semester. Let's jump into it very quickly. For example, the lab syllabus, we will talk about this. This pertains to the entire semester, and then we're never going to talk about it again. So again, it's going to be a little bit of a long lab, and I apologize. Lab schedule and location, labs will be here every Wednesday from 9 to 10:50 a.m. That does not vary. You should not make plans during that time frame, right? So don't make plans to go to lunch or to work out or whatever it may be. Every Wednesday from 9 to 10:50, we will be here in lab. Granted, sometimes we will be done a little bit earlier than 10:50, but just in case, don't plan on it, right? So for the next 3 weeks, we are done at, I don't know, 10:30 every time. Consistently, we're done at 10:30. I don't want you to, on the fourth week, make plans for 10:45. Like, man, we've been done by 10:30 every day. Then that would be your luck, right? Then we'd be stuck until the 10:50. So plan to be here from 9 to 10:50. Any questions about that? Okay, and again, make sure you're on time. Normally that door will be closed with the door locked, but this is the first week, so it's different. Can't come in late because that's not fair to your classmates. Pre-lab worksheets, we've already talked about it. You guys already know, you've already done one. They're due every Friday. Make sure you do not miss that due date. I have to make sure that you're prepared to come to lab. If you don't do the pre-lab worksheet, like some of you haven't, moving forward, I mean, you'll get a 0 for the pre-lab, which sucks for your grade. But also, when we do the experiment, you'll be in your own group. You'll see very often I break it down into groups. Like you do experiment number 1, you do experiment number 2. So when that happens, if you haven't done your pre-lab, you'll be in a different group that doesn't get to do any of the experiments. You just have to sit and watch. And again, if you didn't do the pre-lab, you're not going to get the full grade. So do the pre-labs. Again, make sure you let me know if you need help with those. Those aren't tests. Those aren't quizzes. I'm here to help you. I will literally just sit online while you read the pre-lab, just in case you have a question. Like, oh, wait, what is that sentence trying to say? Or what exactly are you trying to ask here? I will sit there and be there with you and for you and hold your hand and walk you through it. That's what I'm here for. Take me up on it if you need it. Any questions about pre-labs? All right. Oh, yeah, another thing. Speaking of points, those are worth 5 points, right? So each pre-lab is worth 5 points. You're going to make yourself a copy, like I already talked about. Then, when you're done with that, you're going to open that copy back up, as I'm hoping you guys have done for today. You're going to go back to that worksheet that you filled out in the pre-lab and then fill out the rest of the worksheet, which is what we're doing today. That's worth 15 points. Technically, that is due today. It is due today. It's due before you leave. That pass is due on Friday. Well, basically what that means is you should work on it and get this done before you leave. But if there's some questions you just couldn't answer yet, it's okay if you don't get it turned in until Friday. Does that make sense? Okay. Submitting lab worksheets, I can show you how to do that. We talked about it earlier. Basically, you're just going to go to WVSU online and upload the PDF. But again, when it comes time for you to submit it, if you do it today, you just bring it up here if you need, and I can show you. If you do it after today, I can meet you online and show you how. It might seem complicated, but once you do it the first time, it's pretty simple. Already talked about all that. Already talked about that. Yes, students are permitted to print labs. Yeah, if for any reason you ever want a printed version of a lab, let me know beforehand, and we'll make arrangements. Just like one of you, at least one of you needs a computer, and we have somebody or a TA who will make that happen for you. The official late work policy. This is a big one. I've already said this before. I'm going to reiterate it. Officially, late work is not accepted. Unofficially, just go ahead and do it. Don't even ask. Just turn it in, because unofficially, especially with pre-labs, right? So if I get around to grading it, let's say you turn it in, you're supposed to turn it in on Friday. Let's say you don't turn it in until Saturday morning, but I don't get around to grading it until Monday. As far as I'm concerned, if when I get around to grading them all, if it's there, you're good. So again, for anything, this lab included, late work is officially not accepted, but unofficially, go ahead and turn it in. The sooner you turn it in, the better. And it may be a situation where maybe I don't grade any of your late work, and then at the end of the semester, I'm looking at your grade, and you're only a few points away from the next letter grade. Then I'll go back. I'm like, all right, let me see this late work they turn in, and then I'll grade it just enough to get you boosted up to that next letter grade. Make sense? All right. Lab materials. Again, if you can, you're definitely going to want to bring your computer to lab, because you're going to fill out the worksheet online, even though we're doing in-person labs. But also, if you don't want to, you're more than welcome to just take notes. So for that reason, I always recommend bringing some scrap paper. Hopefully we'll bring some scrap paper, bring some pencils if you have them. Today, because you probably weren't prepared for that because I didn't tell you to be, we have pencils for you to use. And we have graph paper for you to use. So it's all provided for you. And calculators. just in case your phones don't have calculators. So any questions about lab materials? All right, behavior and attendance. Again, make sure you're here on time. That's very important, just to be fair to your classmates. Everything else is pretty common sense, right? Just act like adults. So don't be playing around. Don't talk when I'm talking. Yeah, normal stuff. Lab report, we'll talk about that later in the semester. You do have one lab report that's due this semester. It's going to be worth 20 points. So essentially it's the same point as a single lab. So what we're going to do is we're going to have a photosynthesis and respiration lab. This is going to be like every other lab. You do a pre-lab, you come in, you do the experiment, you turn in the lab worksheet. That in itself is worth 20 points as normal. But then you're going to write a whole report on the lab, and that'll be worth an additional 20 points. So if you click this link, it'll show you the rubric. And yeah, anyway, I'll also provide that rubric. So before we get to that lab, there's going to be a whole lecture devoted to teaching you how to write a lab report. And I'm really going to dig in on how to do that experiment just to make sure that you're very aware of how to do it. Anyway, yeah, so any questions about the lab report? Again, we'll cross that bridge when we get there. I also want to point out this. You can get extra credit for any of these labs. You only have to write a lab report on one lab, that one that I tell you when we get there. But for any of these labs we do, you can write a lab report. It'll be good practice for the actual thing, and you'll get extra credit. So if you're interested in that, let me know after the lab, and I can help you through that. Anyway, points. As I've already mentioned, here it is in writing. The whole entire worksheet is worth 20 points, which breaks down to 5 points for the pre-lab, 15 points for the rest of the lab. And again, you're going to have a lab report later that's also worth 20 points. Add all of that up together, and the entire lab section is worth 300 points. And remember, the entire course is worth 1,000 points, meaning the entire lab section is worth 3 letter grades, which hopefully doesn't intimidate you. Hopefully that gives you a little bit of help or inspiration. So if you're bad at testing, or if you feel like you're not good at science, none of this grade has anything to do with intelligence or test taking. The only thing that affects this grade is being on time, being present, and putting in the work. So that's 3 letter grades, right? So you could have potentially have had a D, but because of this, maybe had an A, right? Because you put in the work. So I'm hoping this helps. Anyway, any questions about the point breakdown? All right, miscellaneous. Many of these labs require students to take and insert screenshots. Oh, yeah. So there's information on how to do screenshots there. But again, if you need me to show you, I can show you. When I say screenshot, I don't necessarily mean like it could be an actual screenshot, or you could be looking at watching a video on your phone or on your computer, and then with your phone, just take a picture of your computer, right? Any way you want to do a screenshot works. Let me know if you need help with that. So any questions about the lab syllabus? All right, you guys are nice and easy. Let's move over to this. Laboratory safety. This is important. I'm not going to test you on it, but this is still important. All right, I like number 1. Think safety first. So that pretty much covers everything. Because there's some stuff there's a lot of stuff that's not on this list. For example, nowhere in this list of rules does it say, do not bring a rabid raccoon to lab. It doesn't say not to do that, right? But according to number 1, think safety first. So if you bring a rabid raccoon to lab, that's not safe, so don't do it, right? So that's our catch-all, think safety first. Number 2, no food or drink. Today, don't worry about it. Cheers, right? But in the future, we will be working with some chemicals, and technically, if anyone asks, I said don't bring it in at all, right? So if we get caught, just say, I told you not to. Anyway, leave your drinks out here and your food on the way in. Sometimes we work with dangerous stuff in here. More importantly, sometimes other people work with dangerous stuff, and they should be cleaning up after themselves, but they might not. So you might have a drink right now on the table where they were dissecting a pig, right? And should have cleaned it, but didn't. So think about stuff like that. So no food or drinks in lab. Technically, if anyone asks, not in lecture either, but I'm not going to enforce that. I will enforce the lab thing. I don't want to get in trouble. Any questions about that? All right, here's another one that I didn't tell you about. And this is luckily for us, it's January, so I probably didn't need to. You have to wear proper attire. Today, it doesn't matter. Moving forward, you have to have closed-toed shoes and pants. So no shorts, no flip-flops, no Crocs. Right? Closed-toed shoes and pants. Technically, other things too that include safety. You don't want some long, flowy robe. I don't know why you would have one, but that wouldn't be safe because you'd be knocking things over with your big wizard sleeves. So just think common sense. But again, closed-toed shoes and pants, that's the big one. Later in the semester, that'll be more important because things will be warming up and you might be wearing shorts. You might forget that rule. What I did when I was a student, and I didn't live on campus, so in my trunk, I kept a pair of sweatpants, I kept a pair of shoes, because even though I was a biology major, I would still forget, oh yeah, I have lab. So I'd run out, grab my stuff, put it on, and everything would be good. If you live on campus, it's not so bad. You can sit through the pre-lab, then go run back to your room and change, but then you're still gonna miss stuff. Any questions about number 3? All right, number 4 is pretty simple, no fooling around. I'm not even gonna talk about that, that's just common sense. Exercise extreme caution with open flames. Again, common sense. Currently, there are no plans to have open flames in any of our experiments, but things change, so we'll see. This one's kind of a big one because it's not common sense. Report any broken items to your instructor immediately. Do not attempt to handle broken glass. I say that before. That's important because, again, it's not common sense. If I was a student and I dropped something and broke it, I'd be like, okay, I would just pick it up and throw it away. And normally that's what you should do, but just to be safe, don't do it. Let us do it. We don't want you to get cut. So yeah, any questions about that? All right. This one I'll remind you of when the time comes, but keep all unnecessary items away. Today it doesn't matter, but later, like next week, for example, each row will have some acid and some base and some other chemicals. So you're going to want to have a nice area to work with without a bag and stuff being in the way. And again, I'll remind you when that time comes. Any questions about number 7? All right, this one's big. Actually, I should have swapped this one. Number 8 should have come after number 6. Report all accidents and injuries to me immediately. Don't wait. Do it immediately, even if it seems something small. Again, that broken glass thing, right? So if you accidentally nick your finger on a piece of broken glass, it probably doesn't need anything, but we should at least document it because it might turn out to be something disgusting that somebody else did previously, like I was talking about. And you might get a really bad infection and have to go to the hospital and have thousands of dollars of hospital bills. You need to tell us that, so if we document it, it's paid for. If we have no documentation that that's where you got your cut and that's where you got your infection, then you're on your own. Make sense? All right. We don't really deal with too many hazardous materials, but when we do, there's going to be different manners of disposing of them. So when that happens, we'll tell you. Like, all right, when you're done with this, leave it on the table. Or when you're done with this, put it on that cart. Or when you're done with this, dump it down the drain. Whatever, we'll tell you what to do when the time comes. Any questions? All right, familiar yourself with the location of the emergency eye wash station. Again, we're not dealing with too much dangerous stuff. We need to fix that now that I think about it. So the emergency eye wash station is back there. It's that green thing. You should have a thing of water in it, but it does not appear to be. So we'll fix that between now and then. But anyway, that's where you go to rinse your eyes out. Of course, you can also use the sink, but that way it might be easier because then you can just put it up there and squeeze it out. So any questions about that? All right, know the procedures for shelter in place. How many of you have done a shelter in place here, a drill at WVSU, a shelter in place drill? Just one? It might be time then. They might do another one sometime soon. It's been a while since we've done one. So basically what happens is when you hear the alarm and you'll hear me, I'll say, oh, shelter in place. What we'll do while we're in this building is go down to the basement. You have to do it quickly, orderly, grab all your stuff, go. But do it, like I said, quickly and orderly. And it might not be a drill, so don't take it serious just in case. Because when we get down there, they have a procedure to sealing everything off, and hopefully we'll be safe. And also, if we are not safe and we all die, it'll be useful for them if all the dead bodies are in one place. So help out the dead body counters, and let's get it together. Any questions about number 11? All right. Number 12, be considerate of others. Clean up after yourself. Pretty simple, right? And again, if there's anything specific, like, oh, that chemical you need to put back here, we'll tell you. But just generally, if you bring in trash, take care of it. If you make a mess, clean it up. Common sense stuff. So any questions about that? All right, here's another huge one. If you have any concerns about safety, I consider myself pretty safe. There's a lot of things that I know people don't like about the way I teach, and that's okay, but safety is not one of them, I don't think. I think I'm very safe. But just in case, if you do have any concerns with the way I do things, let me know. If you don't feel comfortable letting me know, maybe for some reason you're scared to, let the TA know, let Logan know. You can tell me, like, dude, you got to quit doing the flamethrower in class. But he won't tell me who told him, so it'll be nice and anonymous. And if you don't feel comfortable telling either one of us, maybe we're both doing it, maybe you don't like the way we throw knives at each other. Here's the phone number you can call to tell the university that it's not safe and they need to take care of it. So any questions about that? All right, and the last thing, as I've already said 1.5 million times today, Make sure you are on time. Again, I'm very strict about that for lab, because when you're late to lab, it affects your classmates. So I just won't let people be late to lab. So that's it for laboratory safety. Any questions about laboratory safety? Get there. Do you have anything to add to laboratory safety? All right. Really quickly, I know you've already read this, so I'm going to go through this very quickly. Graphic, right? You've already read it. If you didn't, go ahead and read it. Read it. Let me know if you have any questions. This gives you all the information you need to know about how to make a graph. The only thing I'm going to talk about is the mistakes I see people make all the time. First of all, if you're going to make a graph by hand, you have to use graph paper, right? So, and we'll hopefully always provide you with graph paper, but just in case, you might want to get yourself some. Always do graph papers if you're going to do the graphs by hand. That's a big mistake that I see. The other big mistake I see is titles and labels. Every graph needs a title, and it should always start with figure. So today, when you do a graph, it should say figure 1, and then the title, right? So figure 1, and we'll talk about what the title will be later. But it should always start with figure 1. People always mess that up. Figure 1, and then give the graph a title. The title should describe the data. So a graph title that will make you lose points would be figure 1, lab 1, right? Lab 1, that doesn't describe the data, right? Describe the data. Again, if you need help with that, let me know. And then the axes, make sure you label your axes. Like, all right, so for example, today's, as I'm going to show you later, the x-axis will be, let's see, oh, that's hard to read. Let me think. Height categories, I'm just going to abbreviate. Height categories will be the x-axis. And on the y-axis will be your finger span. And again, I'm going to abbreviate. So F, S, and then, and this is where people mess up too, if there's units, make sure you include the units. For example, today, as you're going to see later, we're going to measure your finger span. That's going to be in centimeters. So finger span, parentheses, CN. Make sense? All right. So that's basically it. Again, I know you should have already read this. And if you haven't, go ahead and do it, and then let me know if you have questions. Those are the biggest mistakes I see. Another big mistake I see, I think this might be the last one. If you're doing it by hand, you're going to want to take up as much graph as possible. So if you have a whole graph paper and you've got a little bitty corner, you might lose points for that. The idea is to present your data, right? Give the story of your data. And you can't do that if you got a little tiny graph. So anyway, I will talk more about graphs today. When we do our experiment, I will give you some advice on how to do today's graph. So any questions about graphing? Okay. Remember, you can do it by hand or computer, however you want to do it. But if you do it by hand on paper, you're going to want to use graph paper. Do you have anything to add about graphing? All right. Oh, another thing too. Sorry, this is the last thing about graphing. Obviously, that's its own document, right? Graphing has its own document. And from here on out, for the rest of the lab worksheets that you do, whenever it tells you to do a graph, there's going to be a link to that. So if you ever forget how to make a graph, click that link, and it'll bring you back to that document, and it'll explain how to do the lab. What else? Graphing, videos, yeah. All right. So really quickly with the pre-lab questions. Let's see. Can anybody tell me the answer to this one? How much is one lab worth? So the lab you're doing today, including the pre-lab that you've already done and what you're going to turn in today, how much is today's lab worth? How many points? 20. Good. I love it. Everybody either got that right, or if they got it wrong, they had a very logical wrong answer, which was 300. Because they thought, how much is the entire lab section worth? Because it does say lab. So if you got that wrong and you got 300, don't feel bad. At least your brain was in the right place, but it just so happens it's 20 points. Which is a good point. Really quickly to point this out. A lot of these pre-lab questions, they're not even that important always. Sometimes it's just proof that you read what you were supposed to read. So make sure when you answer these questions, they always come from the information presented. So if it says, what is 1 plus 1? And you read the introduction, and the introduction says 1 plus 1 is 10, then the correct answer to what's 1 plus 1 is 10. All right? It's just proof that you read what you're required to read. What are the 9 steps of the scientific method? I'm not going to ask anybody to spout that off. I think everybody got that correct. Again, rule number 12, I don't remember what it was. I think it was to be considerate of others. That one's not more important than any of the other ones. It's just proof that you read it. What do graphs provide? Again, just proof that you read that document. And the most important thing I think you should know is a graph, regardless of what that says there, a graph tells the story of your data. That's not the correct answer to number 4, but that's just what I want you to know. How about this one? When we grow these plants, right? We grew a set of 5 plants. Each one of them had a different color of light. We only measured them once at the end, right? So we planted the seed, and at the end of the experiment, we measured them, and these were the numbers. So what kind of graph would we use to represent that data? And some of you, I mean, almost everybody got it right, and you would know if you got it right or not. So what's the answer to that question? What kind of graph would we need to present this data? Don't be shy. Bar graph, right? Because all we have is like this plant got that tall, this plant got that tall, that plant got that tall. Now, somebody did put line graph, and line graph would be acceptable if we measure these plants, I don't know, once a week. So if we had for plant 1 data once a week for 5 weeks or whatever, then we could make a line graph, and each one of those plants would have their own line. Does that make sense? That's why it's not a line graph. That's why it's a bar graph. All right. Regarding that experiment, and I've already said this in lecture, but I'm going to ask it again anyway. Regarding that experiment, which one of those was the independent variable? The height of the plant or the color of the light? Good, the light, right? Because we're saying that the height of the plant depends on the color of light that we drew it in. Good job. What is the key aspect of experimental design? Again, that's just one of those questions to prove that you read it. And the answer is reproducibility. Yeah, the rest of them. Yeah, we'll go ahead and talk about this. All right, assume you were given a set of plants to use in an experiment that you choose, right? Any experiment that you choose. Write one question you might ask about this set of plants. So, and I'll just use this example. Do plants grow better in certain colors of light, right? That's a question that we could answer in an experiment. So hopefully you came up with your own. Does anybody want to share theirs? You don't have to if you don't want to, but does anybody want to share what your hypothesis or question was? All right. Anyway, one person got it wrong, and I'm glad they did because I got to leave some feedback. And I think the only thing they did wrong was it wasn't really a question that was testable. I forgot what the question they had, but this wasn't it. But for example, if you said something like, "Which plant looks prettier?" Right? That's not a question we can answer. That wasn't what they put, but that's not a question that we can answer in a scientific experiment. So your question needs to be something we could test. Some people miss this. So after you provide your hypothesis question, you need to provide a hypothesis, but those things have to go together. So if you thought, again, a bad example, but if your question was, which plant is prettier, then in your hypothesis, you should say like, the rose plant is prettier than the cactus plant, whatever. So your hypothesis should have addressed the question that you formulated. Any questions about those two? All right, this last one, you're gonna see this kind of question a lot throughout the semester, so I just want to get feedback now. These are just proof, like if you read those directions, say, all right, this is it for the pre-lab. But before you come in the lab, you need to read the entire lab so you're coming in prepared. After you've read the entire lab, come up with one question or one sentence that demonstrates you read the entire lab. The only people that missed it were the people who gave me information that came from the pre-lab. Like, I already know you read the pre-lab. That's what these questions were for, right? This was to make sure you read everything else. Does that make sense? That'd be a common theme throughout the semester because I want to make sure you read the lab before you come in so you're prepared, so you're not screwing over your classmates. Anyway, any questions about the pre-lab? Good, let's jump into it. Now we're going to do the actual experiment. Turn the slide back on. All right, what is this? So really quickly, let's just do some observations. If you can, everybody just stand up, and hold your hand out, and everybody just observe each other. Just look around. Everybody stand up and do this. Everybody just look at each other. Observe each other as they're doing this. Make sure you hold your hand out like you're giving like an imaginary high five to everybody. All right, so everybody's looking at each other. All right, what you just did there was an observation, right? You guys can sit down now. That was an observation. Now you guys hopefully have read ahead so you know where I'm getting at. So for those of you who know what I'm getting at, don't get there yet, don't jump the gun. Pretend like you don't know what we're going to do today. So based on these observations, can someone just give me some questions that you could ask based on what you observed, but not the question that we're actually going to answer today? I'll give you one to start with. Based on me looking around the class staffs, the males in this class have darker hair on average than the females. Because I observed all the different males and females and different colors of hair, right? That's a question I could ask based on the observations. What's another question that we could ask? Based on the stuff you saw. Need at least one before we move forward. Yes, don't be shy. There's so many options. We all stood up. We all saw what everybody looked like. Nothing. Nobody wants to go over one. We won't move forward till you do. Someone do it. Be brave.
Choice of clothing.
Choice of clothing. All right. Yeah. So, like, what kind of question could we, if we were turning it into a question, what could we have? Like,
Do males have on darker colors?
yeah, that's something we could test, right? Good. All right. So, based on that question, do males have on darker clothes than females? When you really break it down, if you want to make it really simple, there's two basic hypotheses to that question. Does anybody know what they are? And again, the question is, do males wear darker color than females? And when you think about it, you make it really simple. What are the two hypotheses for that? You could have a lot more if you got really specific, but the two basic hypotheses for that question are what? Do males wear darker clothes than females? Or are they? Two hypotheses.
Yes and no.
There you go. Yes, they do, or no, they don't. Nice and simple. All right. That being said, now we're going to talk about what we're really doing here, right? So what we just did is your answer to number one, right? So hopefully you should come up with a question based on your observations. Write that down for number one. Then make sure you write a hypothesis based on that question you just asked. Make sure your hypothesis matches your question. So for example, if you say, one question I have is, do males wear darker clothes than females? And then if your hypothesis say, males have bigger feet than females, like, what? That has nothing to do with your question. That's a valid hypothesis, but has nothing to do with the question. So make sure for number two, it matches number one. Now that we have your question hypothesis, here's the actual question being answered in this lab. Is there a correlation between height and finger span? So we all stood up. You saw how tall everybody was. You saw how wide their hands are. So that's the question we're going to answer in this lab. Is there a correlation between height and finger span? Now, since she had to say the correct answer earlier, I'm going to ask her again. Sorry to put you on the spot. But what are the two basic hypotheses for that, Ika? Is there a correlation between height and finger span? If you were to be really basic, what are the two basic hypotheses for that?
Yes and no.
Yes or no, right? Yes, there is a correlation. No, there is not. So choose one and write that down for number three. And if you want to, you can get specific. You can say something like, the taller someone is, the wider their finger span. Or the shorter someone is, the narrower their finger span. Or the taller someone is, the shorter their finger span. Whatever it is. You can get specific if you want. But at the very least, either yes, there's a correlation, or no, there's not a correlation. And that is the answer, your answer to number three. It's a good time for me to tell you this. For the most part, you can never get a hypothesis question wrong in these labs. You'll see later, some of them, there are some exceptions. I won't even get to it now, but as long as your hypothesis makes sense, you're not going to get it wrong. And that includes doing the experiment. So today, when we do this experiment, if your hypothesis turned out to be wrong, you're not going to lose points for that. There's nothing wrong with a wrong hypothesis. The only thing you'll lose points for is if your hypothesis was wrong, and then that question later asks you, was your hypothesis incorrect or incorrect? If it was incorrect and you said it was correct, you're going to lose the point. That makes sense? Or vice versa. If your hypothesis was correct, and then it asked you if your hypothesis was correct and you said it was incorrect, you're going to lose points. So it's okay to have an incorrect hypothesis. But the important thing here is you'll be able to analyze your data to determine if your hypothesis was correct or not. Which brings me to one more other point. Sorry. Yeah, that's going to be a very redundant question. It's probably going to irritate you. But at the end of almost every experiment you do in this class, this lab, there'll be a question that says, what was your hypothesis and was it correct or not? So yes, I'm going to ask you to repeat your hypothesis. Yes, I could go back and look at it myself, but I want you to. Because what happens often is students, once they write down their hypothesis, they forget about it. So by forcing you to rewrite your hypothesis, I'm forcing you to think about your hypothesis again. Anyway, extra credit, you can write a prediction, right? So you have your hypothesis. If you want to, you can write a prediction. Remember, a prediction is an if-then statement that describes how you're going to test your hypothesis. So for example, the way we're not going to do it, but if this was the way we were going to do it, you could write this hypothesis. If every student looks up how tall they are and how wide their finger span is and writes it on the board, then I would find there is a correlation or whatever. But we're not going to look it up, right? How many of you don't know how tall you are? Right? Everybody knows how tall they are, but nonetheless, I'm not going to have you write your height. I'm actually going to measure you, despite the fact that you know. Anyway, that's the extra credit. Here's another extra credit. What sample size should we use? That's gonna be a big thing. This is a 100 level class, so we don't deal with statistics. We don't deal with sample size, but in real life, you would. So if you want to, you can do some, look this up. The information we find here, whenever we figure it out, our conclusions cannot be applied to the entire human race because our sample size is too small. So what I'm posing to you for extra credit is, how many humans would we need in this experiment to be able to look at those results and say, yeah, that applies generally to the whole human race. But again, extra credit, you don't have to do it if you don't want to. Any questions so far? All right, now we get into the meat and potatoes of things. Let's talk about the experiment. Let's design our experiment and then do it. So there's two things we want to measure, right? Because we want to see if there's a correlation between height and finger span. So what are the two things we're going to measure? Because I just said it. Height and finger span, right? So let's talk about measuring height. Again, we're going to measure it. You all know how tall you are, but we're going to measure you nonetheless. So I'm going to go ahead and tell you we're going to use these meter sticks, right? We don't have like one of those nice little doctor things where you stand under it and it does this. We're going to do meter sticks. So before we do this, what are some things we should agree upon before we start measuring? All right, let me ask you this. How tall are you? What is it?
6 foot.
6 foot. All right. He's 6 foot. I am, I think, 189 centimeters. Now, do you see an issue with that? What's the issue? We were both correct. Well, I might not be. I don't remember. But anyway, he said feet. I said centimeters. So if we all just go put their height up there, we might have some issues. So what's the first thing we need to agree upon? The units, right? And I'm just going to go ahead and give it to you. We're going to do it in centimeters. So we're going to do height in centimeters. All right. So what's going to happen when the time comes, I'm not doing it quite yet, but I'm going to put this here like this. Let me get that out of the way. I'm going to have this right here. You're going to stand up right here, facing that way. And then I'm going to look and I'm going to tell you how tall you are. I'm going to tell you how many centimeters you are. What are some things that we should consider when we do this? Because remember, we only want two variables, the height and the finger span. So how can we eliminate some other variables? When you guys come to do this, what are some things we should agree upon? Kind of giving a hint. I'm not just standing like this because I'm a weirdo. I mean, I am a weirdo, but that's not why I'm standing like this.
Everybody.
Good. That's a good one. Taking your shoes off. Now, I'm not going to ask you to all take your shoes off, but later there's a question that's going to say, what are some flaws in the experiment? That's one of them. Because you're all going to have shoes on. Some of them have thicker shoes, soles, some of them don't. So we're not going to do that, but I'm glad you mentioned that. Remember that. That'll be a question later. What are some other things to consider? There you go. Stand against the wall. Good. So don't stand here. Be very against the wall so I can get a better view. What else? Me standing like that didn't give you any hints? Your stance, right? Yeah. Let's all agree not to stand like this. Put your feet together and stand up straight and do that, right? All right. Then one more thing. There's probably other things, but one more thing I want to consider before we move forward. It's a flaw in the experiment. I'm not going to do anything, just like the shoes. I'm not going to ask you to get barefoot. But what's at least one more flaw in what we're doing here that I'm not going to ask you to fix? Your hair, right? I'm not going to shave all your heads. So just, again, some flaws in our design. And another flaw, again, is I'm eyeballing this. So if we were to do this a better way, we would actually use an actual apparatus. So there we go. Now we know how we're going to do height. Now we just have to figure out the other thing, which is finger span. We're going to measure the finger span, right? What's the first thing that we figured out when we were talking about measuring height? What's the first thing we agreed upon? Units, right? So we'll do it again for this. We're going to do it in centimeters. So what are some things we need to say? I can't just say right now, all right, everybody, go measure your finger span, right? That's not going to work because we have to come up with some ground rules to make sure we're measuring the same thing. We already know that we're going to do it in centimeters. What are some other things we need to know? Let's see. This is going to look horrible. We got a fat hand. Anyway, so what are some, that's actually too bad. Anyway, what are some things we need to decide upon before I say go measure your hands? Now, granted, this is in writing. It is written down, but let's pretend like this is not written in the procedures. What are some things that we need to consider?
Where we measure.
Good, where we measure. For example, this is also really bad. It's really bad. I'm not an artist. That's supposed to be a thumb. Man, that is really bad. Anyway, yeah, where are we measuring? For example, if one of you measures from your thumb to your pinky, right? And then someone else measures from your pinky to that finger, there's gonna be huge differences. So let's go ahead and agree upon where we measure. So I'm gonna go ahead and tell you now, even though that's a horrible drawing, we're gonna measure on our right hand between our first finger and our second one. Make sense? We're gonna measure these two fingers. Now, when we consider these two fingers, what are some other things we need to consider? And it still goes back to what the last person just said, where we measure, but what else do we need to consider when we're talking about where we measure? Any guesses? Top or bottom, right? If someone's measuring their finger crotch here, there's probably a better word for it, but I call it a finger crotch. And then someone else is measuring from up here, that's gonna be a problem, right? So let's go ahead and agree that we're gonna be measuring from the top, not the bottom. And there's only one more thing to consider. Well, there's probably other, but at least one more big one. So we've agreed that it's gonna be these two fingers. It's gonna be at the top, not the bottom. What's one more thing to consider?
Outside or inside?
Perfect, thank you. Outside or inside, right? So again, if one person measured here and another person measured here, that would be a big difference, right? So we're gonna do top of the fingers, inside. So you can see how they got that little crease, that knuckle. Let's just agree from there, that to that on the inside. We good? And one more thing to consider, there's a lot of other things, but one more thing that I'll tell you is when you're doing it, get your fingers as far apart as you can without pushing them far apart. Does that make sense? All right, we're almost done here. So what we're gonna do then, I'm gonna measure you. And I guess you can help make sure they put it where they need to do it. I'm gonna measure you, and then you're gonna come up here and you're gonna put your data on the wall. So this is under categories. So if you're 137 to 147, basically, centimeters, you're gonna write your information here. You're gonna write your height and your finger span. If you're in this category, you'll write your height and then your finger span. If you're in this category, so on and so forth. So make sure you're in the correct category. You're gonna write your height and your finger span. And then you keep all that data. Now, what you're gonna do on your own, right? So all this data is gonna be on the wall for you. What you're gonna do on your own is you're gonna calculate the average on your own. And when I say on your own, what I mean is we're not gonna do it and put it on the table or on the wall. But you don't have to do it on your own, as in I can help you. So when it comes time for you to do your average, come to me, I can help you, I'll show you how to do it. But we're not putting it on the wall. I want everybody to have their own individual averages that they come up with, okay? What's another thing? Let's just do, all right, for example, let's just say you're 187. If I say you're 187 centimeters, we'll just say that, right? 187.0. So let's just say 1 decimal place. Same for your measuring of your finger span. You might say it's 6.1 centimeters, right? That we'll deal with. We won't do 6.12, right? We're not gonna do that. That's too many. We're also not gonna do 6, right? That's not enough. So let's just all agree 1 decimal place, okay? All right, so again, we're gonna line up. I'm gonna measure you. You're gonna take your measurements. Then you're gonna put them on the wall. And once everybody's done that, you're mostly gonna be on your own, but we'll be walking around and coaching you and getting you to the end here. So here we go. Let's do it. Everybody stand up and come over to me, and let me tell you how tall you are according to these horrible measurements. Now, obviously, the correlation between height and finger span is very unimportant. This is just an exercise to get you familiar with hypothesis testing. If it was important, we would take your actual height, right? All right, face that way. There you go. Let's call it 184 centimeters. So then you can get a, there you go. You are, let's call it 171.
You go ahead and take the measurement.
So you do the fingers?
You can do it. He's just showing you. If you need help doing the fingers, he can show you. Otherwise, you can do it on your own. All right.
This is our centimeters. We're measuring in centimeters.
6. That's all right. All right, 191. And again, you don't have to wait in line. You can if you want. But the rulers are there, so you can measure your own.
So we go from 1.
Or you can wait.
6.5. We're missing our
It
lights.
might not have been you.
So 1 minus 6.5, 5.
Come on, there we go. Sorry about that. 100 and.
So we're going to make sure we're centimeter up. We got our 2 fingers. I start from
Let's
1.
call it 100
And so mine goes from 1 to 8. So it'll be 7.
Like that?
Was that
Yeah, but these creases
How tall are you?
we're measuring
Oh,
from
okay.
inside to
184?
inside.
Yeah, you'll be in
back.
that category.
Uh,
So you write your height on the left column.
Put the inside
and your
of the
finger
screen.
span on the right column.
Yep.
okay,
You are
so
174.
Yep. Exactly. So
100. and
let's say you're from 1 to 7.5. So where are you at?
1.
say 1 to 7.5.
Yeah. So what are you? What's your number?
186. 109.
So you're measuring from 1, right? Not from 0.
Yeah,
So
on mine.
reading 7.5. 7.5 minus 1.
Even though I teach this, I still don't think of metric when I think of height. Even my own height. 182. One hundred and
And I have a centimeter. Exactly.
one hundred and 65. One hundred and 62. One hundred and 77.
Yep, now spread your fingers out.
From inside to inside. From that
Inside to inside, that's your measurement.
Hey, yeah, there you go.
Okay, so right here.
Yep.
Yeah, like 3.5, lines like that.
That's yeah, since we have to do one decimal place, I would say
Inside.
8.9.
I prefer 9.
Yeah,
So
I
then
think
start
it's-
at 0. All right. Thanks.
186.
Yeah, I like starting at 1. And then just take 1 and subtract it from the bottom. I start with.
I think on average, this is the tallest section I've had in a while.
You said 8.9, right?
Yeah.
So I go to 1,
And it goes to 8. So I do 8 minus 1.
What'd you say?
Oh, yeah.
Hey, your fan? 196.
Sorry, I couldn't catch it. So palm up,
Wasn't it right hand?
right hand.
Am I trying to spread it as far as I can?
Yep. And then I start from 1, and then see I go all the way. Mine measures right to 8, so 8 minus 1.
So just as a reminder, all that data that's on the table, you need to put in your table.
So what that makes.
In addition to calculating the average, and again, Logan and I can help you calculate the average if you need to.
Yes,
if you need our help. Another thing about this, you guys are gonna do a bar graph. It's all gonna be categories. So once you do your bar graph on your x-axis, it's gonna be either short, medium, tall, very tall, or extra tall, right? You're not even gonna have the height. We're only measuring the height to figure out what category you're in, right? So you don't have to worry about the height when you make your graph. But if you want to, for extra credit, this would also be a great scatter point graph, which is beyond the level of where we're at right now. But if you are already at that level, you can do a scatter plot graph for extra credit. Because that would actually be the better way of doing that scientifically would be a scatter plot graph. But our point here is to not truly determine if there's a correlation. The real point of this lab is to get you familiar with hypothesis testing and graphing. Should be, yeah. We could round it up to 20.
And then whenever you write 2 per group, you do 1 group in total.
Let's see. You know what? We could ask Doug how he prefers it. Like, so for example, 50 ml beakers, and you're right, right? We need 2 per group. So what we're gonna do next week, I'm glad we're talking. So next week, we're gonna break them down into groups. So each table, they're gonna do the same experiment this time. So 1, 2, 3, 4, 5. We'll have 5 groups. I should call it 4 groups. The 5th group will be those who didn't do the pre-lab, can only watch. Anyway, so we're gonna have 4 groups. So like you said, 2 beakers each. So the way I would do it, and I don't know how Doug would want it. If I was doing it, I would do 50 ml beakers, 2 per group, 4 groups, so 8.
Okay.
And again, you could ask him what he wants.
Okay.
But yeah, so we'll have 4 groups. So yeah, we'll need 2 each of those, 1 acid, 1 base for each. Pipettes, you want to do pipettes? No, because it comes in a little screw. Oh yeah, the pH indicator strip, 1 for each group. I think that's it. Yeah. The models, is that on that model
Yeah.
kit? They hardly ever use them, but I like to have them if they want them. And that's just as many as he has, the box of model. kits.
These on blanks, it was 1 per student, and I wanted to make sure we had 6.
So.
Good.
That everybody's here, so I could fill that in. So I'll go ahead and do 16/4. Yeah, 4 groups.
Yeah, good.
16, 16, 16, 16. I'll get those 2 for this next week's.
Perfect, yeah. And I guess that's due today, is what he said.
Yeah. So we're on schedule.
Yeah.
And I'll be back, I'm gonna fill out some more, and I'll come back for the part.
Sounds good. All right.
Yeah. We're supposed to be transferring this over, right?
Yep,
Okay.
so whatever's on here, you gotta put on your table that's on your lab worksheet.
Okay.
Obviously, you can leave the very short blank. Yeah, just leave it blank. I'm also gonna take a picture of it, because some people were not here. Especially-
I was just gonna ask for the last.
Oh, extra tall?
Okay.
Yeah, sorry, that's hard to read, guys. No, I won't use orange again. If I can help it.
It's really that short.
Let's see, what's some other advice to give you guys?
I should say